Should the government be spending money to create a tool that can automatically inject security vulnerabilities into any arbitrary piece of code? Let's take a look at that. I was at the Software Supply Chain Assurance Forum last fall, and they showed a demo from a tool that the government had funded, specifically DHS, I believe. I'll have to look that up, but I'm pretty sure it was DHS. So DHS has lots of different things that they're chartered to do to protect us. One of those is really cybersecurity, application security, helping to create better tools, stronger standards, getting people on a better footing, making sure there's better information out there, doing lots of actually really, really good work. But in this case, I think maybe they're off on the wrong foot. I saw this demo of this tool, and they show it, and essentially they want to be able to take like a random application that lots and lots of people use, something like maybe a really common email client, or something like MySQL that everybody's using for their database, and inject a bunch of realistic looking security bugs in it so that they can do better research on security tools that are supposed to find bugs. The problem is that they spent a whole bunch of money on this to a particular company whose name I'm not going to mention here, and they created this tool that creates a very narrow range of very simplistic bugs into these real applications. And they succeeded in that they didn't really break the application, other than injecting a security bug, but they didn't create very interesting bugs in it. And so there's a couple of things I wanted to point out here, right? On one hand, do we want the government to do this, and is this a good idea? And on the other hand, what are they trying to achieve, and is this the right way to achieve it? So I think I'll start with, is this a good idea? Okay, so the end result, if they're good at this, if they continue with the research, because they essentially have a successful proof of concept here that says, hey, I can inject a lame bug into an application. We'll talk in a moment about lame bugs versus real bugs when it comes to security assessments or security tool assessments. But let's say that they achieve it. They can inject realistic, nasty security bugs into arbitrary applications. Again, the whole point of that is so that they can test security tools. So I probably should have handled what are they trying to achieve first. Let's shift. The government is trying to be able to figure out, are these tools doing a good job? Are the tools that are out there? There's a test suite called Juliet, for example, which is a bunch of what we call synthetic bugs, meaning there's a small piece of code. It has a very clearly spelled out bug. Test suites often have proper bug and a bug that looks like a bug but isn't really a bug, or a vulnerability or a weakness, so that tools can isolate the difference between it's finding lots of different cases of this, it's finding true positives, it's not finding false positives, and things like that. So these test suites have tens of thousands of tests in them, and they're useful in the sense that they cover a broad range of things, but they're not useful in the sense that the bugs are very unrealistic. So the government has a program called SATE or SAM8, both parts of the same program, and it's Static Analysis Tools Exposition is SATE. It happens every few years, and it's part of the SAM8 program, which is Static Analysis Tools and Metrics and Tools. I don't know, I'll put it in the thing down below. But basically, NIST is kind of the lead on this, trying to assess what is the state of the art. So they put together a test suite that incorporates for SATE not just these synthetic tests like Juliet, but also taking programs like Wireshark, which are really big and complex programs, or other open source, well-used applications that have known bugs, and then they run tools against them and compare the output. So the advantage of this is that they're real applications. Wireshark's a couple of million lines of code, and some of the bugs are nasty and hard to find. So it's a really good assessment. The problem is that if we think about something like CWE, it has 800 items, and there's no test suite that covers all 800. If we try to limit that, the obvious first step is CWE Top 25. And as it turns out, Juliet does a horrible, this is the map from last fall that I made. Juliet does a horrible job of covering the CWE Top 25. And most people aren't even really aware of that. So somebody obviously is, because they're funding research into creating more bugs. So I get it, right? And the Juliet bugs are unarguably simplistic. right? It's a bare minimum, can you find it? And then you go to something like Wireshark or elsewhere and say, and can you find it in a really nasty piece of code where it's buried and tangled in some horrible way? Yeah, worthwhile tasks. Now, we come back to, what are we trying to achieve? We're trying to achieve a test suite that has comprehensive coverage of realistic amount of bugs compared to the standards that are out there, so that we can analyze tools to see, are we, not which tool is the best for purchase purposes, but are we as a society, as an industry, as a security industry, doing a good job? And where aren't we doing a good job? What do we need to improve at? For example, we might be really great at SQL injection, but overall maybe cross-site scripting isn't as well covered by tools. I don't know. I made that one up, just for example. So it's an interesting task, but it's a finite task, right? Like, do I need a tool to automatically create bugs? Well, the answer is you're going to get simplistic bugs when you do that. So if your goal was to improve the synthetic test case generator, then you could do something easier than this and get it done faster and be way more thorough and broad with it with the same money. I can't remember what they spent on this. I'm sure it was too much. It wouldn't surprise me if it was anywhere from $500,000 to $2 million, and $2 million wouldn't surprise me at all, just based on previous experience. So there's that, and then there's the, if my goal is to take real programs and make sure that they represent a breadth of nasty bugs, guess what? There are thousands of people out there in the US alone, really great red team people that know what nasty bugs look like in software, that are really good. They're doing great work at a lot of organizations right now, testing people's applications. You can take some of this understanding and knowledge and turn it loose against a couple, not one application, a suite of applications, 4, 5, 6, 7, 8 really common open source applications, and have them inject real nasty bugs in there. And if you took, say, $2 million and you took a couple of these people and you turned them loose for a year or two, you could do a fine job of the CWE Top 25. And if you went further, you could do a really fine job of the entire CWE and CERT and OWASP and every other security standard. So this is the funny thing about automation, right? Like, I work at a software test automation company, and the things that you automate are things that occur repeatedly, not one-time costs. I need tools to automatically find security bugs because it's a task that I need to perform on a daily basis. I don't automatically need to inject bugs on a daily basis. So I would argue that we've spent a whole bunch of money and we haven't improved the problem at all. And now to go back to my other question, which is, should we be building a tool in the best case scenario? Let's say that the tool is really good at it. And let's say that it can do non-trivial bugs. So now we end up in the same place that we would have ended up at, although probably a much higher cost to create a tool to do it than to just hire some people and get it done, because again, it's a fixed size problem. But now we have this tool. Like, do we want this tool to be out in the open? Will this tool like get out of hand? Hey, we saw what happened with the software, whoever created it, that was used in Iran against their nuclear reactors, and it became rogue virus software. You release a piece of software out in the world, and this is going to end up being like an open source tool, because the government's funding it for open source uses. So like Juliet Test Suite, which is completely open. Do we want that tool out there? Do we want a tool where people can take open source programs, automatically inject nasty bugs in them, and then check it in as a branch or store it on a repository somewhere where someone doesn't realize that they're getting a buggy version of an open source application rather than the real version? I don't see the upside, because the tool doesn't create nasty bugs. And it certainly doesn't create very many realistic bugs, and it's nowhere near solving the problem. And the money that we're spending, the money that we'll need to spend to do the job, we could do it faster, cheaper, without creating a dangerous tool. So those are my thoughts on it. Let me know what you think. Thumbs up if you like the video, subscribe, hit that bell if you want to get notifications. If you've got something interesting to chat about, questions, comments, let me know, and stay safe out there.